In this video, I'm going to talk about the exponential model, and I'll do an example that comes from the data fitting notes, and I'll show how to use MATLAB to solve the problem. The exponential model looks like this. We have two parameters, capital C and little b, and these are the numbers I need to find for my exponential model. The plan here is to take this problem of finding an exponential model, or finding these two parameters, and turning it into a problem of finding a linear model, finding a line. And that problem, as you know, has two coefficients to find. Once we find those, we're going to translate them back into the exponential model. So this process is called linearization of data, and let me show a little bit about where this comes from. I'm starting with the exponential model. I take the log base 10 of the left-hand side and the right-hand side. C times 10 to the bx. The right-hand side I can simplify using rules of logs. First of all, the log of a product is the sum of two logs. And that second term on the right there, the log base 10 and 10 raised to the bx. These are inverse functions. They undo each other. And what I have after I simplify is just bx. So by taking the log of both sides, I now have this equation right here. And what I want you to see is that this looks like a linear equation. Instead of y, I have the variable log of y. This constant is going to be c1. And this term here is c2x. So it's a linear equation. And I'm now going to use the least squares method, or possibly polynomial interpolation, to find those two coefficients and translate them back to my original exponential function. C1, when I find that, is going to be equal to log base 10 of c, and c2 is going to be equal to little b. So we'll see that translation back again at the end of the MATLAB calculation. So here's a problem. It has to do with Apple stock. Since Apple introduced the first generation iPhone in June 2007, Apple stock has been very successful. The table below shows the price per share of Apple stock on May 1st of each year. Find an exponential model for the price of Apple stock and use it to estimate the price per share on May 1st, 2016. So this is a time series problem, and as with all of them, the first thing that we do is to adjust the data set by calling the first year 0 and counting years after that. So I'm counting years after 2007. This would be 2 years later, 3 years later, 4, 5, 2014 is 7 years later, and then 2015, 8 years later. So I'll use those values of x, and y is the price per share. Now let's look back at my overall plan here. I want to find a linear model on the data set x log of y. Okay, so I'm going to adjust or modify my data set. Instead of looking at xy, I'm going to look at x log of y. So log base 10 of y will become a new line on my table, and I'm going to look at the log base 10 of each of these numbers, put those in to MATLAB, and find the line using the least squares formula. Now, rather than calculating the logs of each of these numbers, I'll go ahead and let MATLAB calculate them for me. And let me set up the problem now. Again, I'm going to find a linear model on the data set x log of y. Right, new data set. So what am I going to type into MATLAB? First of all, my matrix A. The model I'm finding is log base 10 of y is equal to c1 plus c2x. I put in each value of x and each value of log y into that equation, and I end up with a matrix equation. 1, 0 is my first year, 1, 2 years later for 2009, 1, 3, 1, 4, 1, 5, 1, 7, and then 1, 8. So there's my big long matrix A. Clearly we're going to have to use least squares here. Then I'm going to type in the y values, the actual y values. This is the price per share of Apple stock, and that is going to be $17.31 in the first year. 2 years later it was up to $19.40, $36.70, and so on. I'm going to just write down all the y values into a matrix called y. So I'm going to let MATLAB calculate the log base 10 of those numbers for me. And I'm going to write it this way, log 10, and in parentheses y. Go into this matrix y, calculate the log base 10 of each of those numbers, and that will be stored in the matrix called ly. And then I'll do my least squares fit on that. So I'm going to type in inverse of A transpose times A times A transpose times ly. So let's go to MATLAB and finish up this problem. In MATLAB, I'll type the matrix A, and that has 2 columns. And I'll type in the y values. This is the price of the stock in each year. Next, I'll form my matrix ly, and that's going to be the log 10 of each of those y values. And then I'm going to do the least squares calculation. Save it into a matrix C, inverse of A transpose times A times A transpose times ly. There I have my C1 and C2. Little b is going to be C2, so I store it in little b. And capital C I'm going to get from C1. C1 is equal to the log base 10 of capital C. And so to find out what capital C is, I take that exponent, C of 1, and I put it on 10. And there I have my C. So now I have my model, which is y equals 15.8007 times 10 to the little b is 0.1167x. Okay, so there's my exponential model. And I'm going to use that now to estimate the price of Apple stock in the year 2016, on May 1st of 2016. For that, I'm going to use 9, and that calculation is going to be capital C times 10 raised to the little b times 9. So I end up with $177 and round it off to 30 cents. Here are two graphs that illustrate exactly what we've done. On the left, the graph shows the data set XY, X being the number of years after 2007, so 0 and the price per share and so on. That's our original data set, and it shows the model that we just found, the exponential model. We can see the data points scattered around it. This is, again, a least squares fit. It's the best fit, and not all of those data points lie right on the model. On the right hand side, I've plotted the points x and log base 10 of y, and we can see that those points line right up, and this is again called the linearization of data. I start with an exponential data set, and if I look at x versus log y as a scatter plot, those points line right up. So I find the line here on this second graph, and I translate those coefficients back to the exponential model. This graph on the right is called a log plot. Log plot, because instead of looking at xy, I'm looking at x log of y.